Good morning, September 15th. We're on site today doing additional training related to the BMS systems, controls, air handling units, energy recovery unit. We're going to look today a little further at some of the submittal data and maintenance data that's been provided as part of the closeout documentation for the facility's use in their long-term maintenance and findings and investments. We are again looking at the rooftop plan view, A building, air handling unit number 1, air handling unit number 7. These are modulating air handling units that operate based on static pressure controls that are mounted in the ductwork systems. These units provide conditioned air to the spaces, which are all in turn handled with additional temperature control throughout a series of VAV boxes that are incorporated within the same systems. So we're going to look at air handling unit number 1 based on its submittal data. It services the 2nd to the 5th floor. We're calling it on the west side of the building. Okay. When you go through the submittals, you're going to see your overall plan of each system. As we look at these units, you'll see the arrangements of the openings as we discussed yesterday with smoke dampers, return fans, cooling coils and heating coils, mixing sections, and additional fans, return fans. Sorry, this is supply, this is return. So as you look at these units, you'll see that exterior of the unit, you'll have your VFD controller, your single point disconnect, and your a control panel. You'll see all your access doors to get into these modules. So when you're up on the roof and you open up these doors, you'll gain access into your fan section. Your double fans are installed in each one of the air handlers. This will allow, in event of a failure of one fan, you'll still have continuous airflow. It will not be 100% capacity. I believe it's approximately a 75% reduction, or you'll have 75% of backup. Okay, this VFD will control both of these fans to operate at the same speeds. You'll see that you have your outside air intake dampers, your mixing damper, your exhaust air damper. Okay, so as the air returns from the unit, based on the requirements of the discharge air set points, you'll have a certain amount of defined air exhausted. You'll have a certain amount of air that returns back through the unit. You'll have a certain amount of air that's brought in from the outside. And then you'll pass through your coils. Okay, your heating coils, your cooling coils, your supply fans, discharge opening in the unit. As you see over here, these are your piping closures, everything related to this unit with relationship to isolation, strainers, balancing valves, control valves, freeze pumps. They all exist within this piping cabinet. So when you're up on the dunnage platforms on the roof, you'll notice that there's a access platform that runs the continuous side of the machine where most of your servicing will take place. And then you'll have smaller platforms that will allow you to gain access to where the control compartment is, as well as the piping cabinet. This is a plan view that you're seeing for air handling unit number 1 and a section view, okay? This is your curbs. All of these units are sitting on factory mounted curbs, okay? These curbs are mounted on top of the steel dunnage. The ductwork drops through these openings, runs underneath within the dunnage enclosures, and drops down into the shafts, which then disperses out on each floor in the buildings. So as you move further down the submittal data, you get into the air handling units, their selections of their fans. Dual fans, 50-50%, shows you all your operating CFMs, your statics, your fan characteristics, design speeds, RPMs. You'll have this for both the supply fans and the return fans. You get into the different segments that exist within the air handlers. Talks about the liners of the sections. It talks about the insulation values, the construction materials that are used, your access door locations with the sizes, handles, whether there's locks, no locks, outward openings, safety screens. Okay, so when you're getting into the units where there are fan sections and the safety screens in locations. Return fan. Okay, you get into your pressures, your CFMs, your statics. All these fans are internally isolated on seismic inertia rails. Okay, so everything is isolated within the unit itself. You'll see that you have 2-inch spring isolators and snubbers with thrust restraints. Talks about the interior construction, stainless steel panels. You have convenience outlet in this section. Okay, it talks about the transducers, the drives, access doors, outward opening doors, motor controls, your fuse disconnects. Okay, again, you start to see some of the communication protocol. These are all communicating on a backnet link. You'll see some of your input and voltage requirements, your efficiencies. These are all part of the submittal data. Okay, you get into some of your economizer segments. It talks about outside air, mixed air, exhaust air, return air. Okay, these are your different values that were all utilized in the creation of this economizer segment, where you see these little notations, EE, economizer segment. You see the FR, okay, the return fan segment. Those are all related to the first schematic that we looked at when we saw the plan view and the elevation view of the unit. It will identify what section those are. Okay, you have your filter segments, your MERV 8 filters, 2-inch MERV 8s, your 12-inch MERV 15s. Again, it talks about the construction of the unit itself. Your heating coils, okay, you get into your heating coil segment, access section, your cooling coil segments. All these things are internally constructed with stainless steel construction for panels. So for corrosion purposes, you're dealing, you have that added protection. Supply fan Same situation, talks about your airflows, statics, sitting on inertia bases, snubbers, thrust restraints. Okay, perforated liner in this section for noise control. Getting into the VFDs, amperages, fuse disconnects. Okay, you see your input, your rated voltages, your input amperages, your efficiencies. Okay, these are all part of the submittal package. Your discharge plenum. Okay, all these different modules are what constructs your one air handler unit. You get into the heating coil, you have your physical properties of each coil. Okay, it gives you the sizes of your coils, gives you your fins per inch, tube circuits, okay, all of the construction information, your supply and return connections, entering and leaving water conditions, your flow rates, pressure drops. Okay, each one of these units is provided with similar data. You have your heating coil, you have your cooling coil, same situation. Shows you your fins, your rows, your airflows, your water temperatures, your flow rates and pressure drops. Your single point power with your main disconnects. And your overall static pressure summary. Your supply and your return. Okay, this is the way these were designed. These are your statics. This is the information that was used to construct these units. Your overall weights of each module, combining to your overall weight. And this basically allows you to see the way the units are constructed with the modules in their order, your physical dimensions. Sound data. Recommended trap construction. Okay, so this is what was used to create these traps that you'll see on each one of the units. And you get into your second air handler. So each one of these air handlers in this submittal follow the same layout. You'll have a cover page that talks about the unit number, the tag, the location served. This is the center of the building. When you're looking up on the B wing drawings, you'll notice that this is what serves your food service areas, your common areas, your administrative areas, 1st through 5th floor. Same layout. Overall plan views. Okay, it shows you your return section, your return fans, your exhaust air, your intake air, your return dampers, filter media, filter sections, coil sections, supply fan sections, discharge plenum sections. All the same information, curbs, fan data, unit tags, construction details, all of your segments that develop into this unit, shipping information, fan information, okay, return fan, supply fan, water coils. All the same information is provided for each one of these units within this data. This package contains everything you need to know related to the design of these units. So as you continue down, you see here you have, 253-page submittal. Okay, so all of the same information happens for each unit, and you'll see as you scroll down, you'll come up to your next air handling unit. Number 3, 1st to 5th floor. This is the east side. This is the B building. Okay, it's discussed in the past. You'll find the same layout, plan views, curb details, fan details, construction of the unit. Okay, everything continues and it follows. All of the units have the same exact outline with all the performance data that's required. So as we stated prior to looking at some of the submittal data, we talked about all these units providing airflow to VAV boxes. So you'll have VAV boxes. There's over 500 of them throughout the building. Okay, they're all controlled by Johnson Controls with their VMA control actuators. All the VAV boxes are provided with a discharge air sensor, control valve. They're all low voltage, 24 volts. There's common power supply panels located on multiple floors throughout the building that provides the 24 volt to power these control systems. Okay, when you're looking at these VAV boxes, this is what you're looking at when you're looking into the inlet of a VAV box. Okay, they're basically airflow stations. They have multiple sensing points to sample pressure over a cross-sectional area, and they're basically traversing the airstream, and that number is being calibrated and calculated to display a CFM reading that you have for each one of your VAV boxes. Again, you can review the product data and the operation and maintenance data to get specific design characteristics. When you're looking at these VAV boxes, every one of them is provided with a controls enclosure. You're looking at the inlet of the VAV, which has your airflow station, your galvanized steel casing. Okay, so all of these things are constructed within a steel casing. You have data on the sides. There's a sticker that will tell you the VAV number along with its design performance, and your low leakage damper. So again, this is a VAV box. Okay, it modulates based on maintaining a temperature within a space. It will modulate this damper for airflow. It will modulate the heating valve for temperature control. They're all constructed of 22 gauge galvanized steel, internally lined. You have a primary air valve, hot water coil, and again, 24 volt power. All of these units have an electrical shut-off switch, so you can disconnect power for service. This is just a little bit more of the different size boxes and dimensional data that you'll see on these. You have a variation from unit sizes from size 4 up to, I believe, a size 16. As the sizes get larger, obviously it contributes to having larger airflows. A lot of them in this building do range between that 6 and 10 inch VAV box. Different arrangements that you'll find. You'll have some that have the control box and the coil on the same side. You can have some that have the control box and the coil on the opposite side. This was all done due to coordination with ductwork layout and piping systems within the ceiling. So you'll have the accessible. The units will be accessible to work on to the best of our ability. These are just some dimensional schedules. Again, the Model TSS VAV box. We're now looking at the Johnson Controls as-built manual. We're looking at a typical VAV box with a reheat coil. There, as I said, there are over 500 VAV boxes installed on this project. They're all very similar with regards to components and hardware and control sequences. All of the VAV boxes have a VMA controller installed within them. Okay, on this VMA controller, you'll see you have 24-volt power. You have your binary points, okay, which is your reheat. You have your universal inputs, which is your zone temperature and your discharge air temperature. And you have your communication link, which is a daisy chain throughout your VAV boxes. You'll see that there's a flow diagram to show you just the general layout of a unit. You have your supply air coming in, your controller, your pressure sensors. You have a damper, okay, you're controlling this damper. Heating coil, okay, the reheat coil with the control valve. Your just discharge air temperature sensor and your zone temperature. You have a bill of materials. Okay, it talks about the discharge air temperature sensor, DA-T. It's a T635. Okay, it's a platinum duct probe sensor, 4 inches long. You have a ZNT, which is your zone temperature sensor, T6350. It's a platinum flush mounted temperature sensor. Your VMA, which is your control valve. Which is your control actuator. And you have your reheat valve, which is listed on a schedule. They're basically all the same control valves throughout. They're 1/2 inch modulating hot water, normally open control valves. You'll see that each one of these flow diagrams that I show you are very similar. The difference that you're going to find is that when you get into spaces where the security range changes, okay, where doctors and stuff are located, the zone sensors themselves will have a readout on them. You can actually see the temperature, whereas the locations where there's patients and circulation, you'll see that there are a stainless steel plate sensor. Okay, that temperature and stuff cannot be displayed on those. You will see them on the front end. Each VAV box has a maximum cooling, minimum ventilation airflow setting. They have pressure independent variable volume control units. They modulate the primary air supplied from the air handling system to maintain their respective space temperature set point. As the space temperature that's sensed by the space temperature transmitter rises above set point, the VA unit control module will modulate the primary air control damper towards its maximum open position. The reheat coil valve should be closed. The reverse will occur when the space temperature falls below set point. As the primary air volume reaches the low limit, the space temperature is still below the set point. The reheat coil will modulate to maintain space temperature. So reduction of airflow will be the first stage of heating. If the temperature still is not achieved, the reheat coil will come into the equation and be modulated to maintain the space temperature set points. The VAV box will discharge air temperatures at all times. If the VAV box temperature discharge air temperature reaches 87 degrees as a maximum, it will begin to modulate the primary airflow and maintain that 87 degrees. You also have CO sensors that are incorporated on numerous VAV boxes that serve high concentration areas. Okay, these CO sensors are incorporated into the universal inputs. Same operation, okay? All that happens is you get into high occupancy areas, such as conference rooms and large classrooms, where space CO2 sensors shall be provided with set points at 800 parts per million, which is adjustable. The VAV damper will modulate to increase primary airflow when the space temperature or CO level is above set point. So again, these VAV boxes have CO sensors in them. They are in areas that have higher concentration of people. The VAV box will operate to bring in more airflow on rises in CO levels. There's also a handful of constant air volume units, approximately 12 of them. Operates basically under the same sequence, the same components. You have a VMA controller, an expansion module. The airflow valves and constant volume control units shall supply the same volume of primary air at all times. The space temperature control is achieved by modulation of reheat coils, and they monitor the CAV discharge temperature at all times. The reheat coil will be okay, so we're going to go back into looking at the overall plan view of the building and look a little more into the air handlers and the VAV boxes. Again, we're going to return back up to AHU number 1 and 7, which is on the A roof. So as the airflow leaves these units and drops down the shaft, it will be dispersed through a riser which exits on each floor, from the 5th floor down to the 2nd floor. Okay, and when it exits each shaft, you'll have a fire smoke damper to provide you your fire ratings that are required . So as you see here, this is shaft number 1. Your air handling unit is sitting up here on the roof. The ductwork runs below the units, inside the dunnage enclosure, drops down into your shafts. Fire smoke dampers to provide you your ratings at your shaft enclosure. Okay, where you exit the shaft, your ductwork splits off into multiple directions. This is a typical layout for air handling unit number 1, number 7, number 3, number 8, number 2. Multiple air distribution into VAV boxes. Okay, you'll see here they're all highlighted in red. These are all your VAV boxes that are associated with air handling unit number 1. The designations of these units is very user-friendly. You'll see it's called VAV-1-512. This is an indication of the unit that the VAV is associated with. Okay, so VAV-1. Okay, as you'll see, all of these VAVs will be provided with a 1. 1. Those mean that they're associated with air handle unit number 1. The 5 represents the floor that the VAV is installed, and the preceding number is the identification unique to that box. So here you see you have VAV 1 5-1, air handler unit number 1, 5th floor, box number 1, box number 12. So you see that you start to have multiple boxes serving multiple locations. It's pretty broken up in this building, so there's a lot of different temperature zones and a lot of control available. As you see here, you have a VAV box, right? This is just serving one comfort room. Your next VAV box is serving 3 bedrooms. Your next VAV box is serving 3 bedrooms. You have a VAV box which is typical that serves the end of each corridor. So you start to see, when you look at the overall layout, we'll be looking at the color of blue, turquoise. All of the VAVs associated with air handler unit number 1, okay, are this turquoise color that you're seeing here. You have common area VAVs that are providing ventilation and air control over the curtain wall systems. Again, that's one large box servicing that whole exposure. Another box which is handling that exposure. So there's a large overlap in zone. There's a lot of infinite control because you have a lot of different means to control spaces. Okay, so the bedrooms all have a VAV box that serves 3 bedrooms. VAV box that serves 3 bedrooms. Activity rooms that have interior and exterior zones. VAV boxes that handle the exterior load of floors. And this is a typical layout that you'll see on each floor for each system. As we look at air handling unit number 7, you see that the VAV boxes, again, are tagged 7 5-9. This VAV box is tied into air handler unit number 7. It's located on the 5th floor. Its unique tag is number 9. This is a bedroom VAV box, services 3 bedrooms. This is a typical layout for a VAV box that serves bedrooms. VAV box serving bedrooms, 3. Activity rooms, VAV 754, serving the exposure, okay? This is your curtain wall exposure. VAV box serving your interior load. This layout happens from floor to floor. As you go down to the 4th floor, to stay true with the colors that we're looking at, your turquoise or blue. Now we're on the 4th floor. Again, you'll notice the VAV box designation number 1, air handle unit number 1, 4th floor, its unique tag. This will allow you to realize quickly where these boxes are, what their number is, and what air handling unit it's associated with. This is typical throughout, becomes consistent on all the floors. You'll see that this is air handling unit number 1. All these VAVs will be provided with a VAV number 1, a floor number, and a unique number. So as we looked at the VAV boxes through a plan view on multiple floors, I'm just bringing you into this schedule. Okay, these are all part of the same VAV box submittal package that we were using before to discuss the parts and pieces of a VAV box and discuss some of their controls. Each one of these VAVs are incorporated into a schedule. Okay, I'm looking at VAV 1.5. Okay, again, this is air handling unit number 1. That's why it's VAV 1-5, meaning that they're on the 5th floor. And then 1 through 14 signifies their unique number. As you go through this schedule, you'll see that each one of these VAV boxes has its own performance data. Okay, you see the manufacturer, the quantity of boxes, which they're all obviously 1, the model of the VAV, which is a TSS, your size, which is based on your inlet, okay, the inlet size, your controls sequence, your airflows, your max, your min, your inlet static pressures, your static pressure inches of water gauge, your heating CFMs, your entering and leaving air temperatures, BTU capacities, entering water, leaving water conditions, your pressure drops, your water flows, rows of coils, circuits, sound data, discharge and radiant. So when you look at these VAV box schedules, all the information related to the physical performance of these VAV boxes are listed. And you'll see that each one of them is individual in the submittal per system and floor. Again, VAVs-1 would always relate to air handling unit number 1. VAV-1, 4th floor, always related to 4. 3rd floor, 4th, see there's 14 boxes on the 3rd floor, related to VAV-1. Unit number, floor, unique designation per that floor. All the same performance values for each VAV box. So when you look through the submittal data, you'll see that there's multiple pages that talk about the performance for each one. Similarly, you'll see here VAV-7, all these boxes VAV-7, that's air handling unit number 7, 5th floor, 18 boxes associated with the 5th floor, unit number 7, VAV boxes. 4th floor, 18 boxes, unit number 7, 4th floor, independent number. You'll see that each unit is similar in layout, always following the same identification designations, all provided with their airflows, discharge and entering air temperatures, entering water, flow rates, sound data, This is a typical for every VAV box that exists within this building. You'll find all these performance schedules within the approved submittal data.